a recognition that crypto is self-binding. The software creates the cryptographic proofs that prevent a large body of crimes that have occurred in the banking and financial sectors, where we can code fairness, where we can code anti-counterfeiting, where we can code security. We need to do that, and we need to recognize the crypto sector can solve problems that traditional implementations just can't.
Hello, everyone, and welcome to the 37th episode of Colors of Web3 and Entrepreneurship. My name is Lum, your Web3 host. For those of you who are new to the show, Colors of Web3 and Entrepreneurship is a show highlighting the journeys of builders and innovators in Web3 and entrepreneurship. Some topics, especially in Web3, may get technical, but we do our best to keep it accessible for most people. And today I am joined by Jay. He's a VP of Development of IDD Labs. And Paul Snow, he is the CEO of IDD Labs and also the lead architect of Accumulate Network. Jay and Paul, can you give a quick introduction about yourself?
I'm Jay Smith. As you said, I'm the VP of Development of IDD Labs, where we're primarily focused on the Accumulate network, building it out. Uh, and I've been doing this for the last 4 or 5 years. And prior to that, I spent a lot of years building big financial systems.
Yeah, I'm Paul Snow. I've been in the blockchain space for quite a few years. I started watching it probably in 2010, possibly in 2009, but I really became enthused in 2013 and started a meetup that I still run, and I've been at it ever since. The Accumulate network that we're talking about today is the reformulation and reconstruction of Factum protocol that launched in 2015 alongside with Ethereum. And we're here to talk about it.
Awesome, cool, yeah. So I mean, for those of you who might have watched the previous episode, Jay actually appeared on the 34 episode. I'll leave the link up here with John Chambliss. But Paul, actually, maybe like to maybe deep dive or get a bit more about you. What did you do before 2010? Were you always been researching in cryptography, blockchain, or what happened before that, like
Well,
before
actually,
the blockchain?
yeah, I started in the digital uh, printing revolution in the late 80s. And actually, Jay and I worked in our first startup back in College Station where we were going to school at Texas A&M. I ended up getting a master's in computer science, and I've largely been involved in compilers and interpreters uh, for use in printing originally, and then later in the 2000s, early 2000s, I uh, developed a rules engine for the state of Texas, which they still use to automate the rules for eligibility determination for assistance programs. What stuff, the stuff that people
Really?
tend to refer to as welfare and food stamps, uh, technically TANF and SNAP today, but there's like
Hmm.
50 programs, and the rules engine runs about 3,000 decision tables currently, and that amounts to something like 30,000 rules.
That's a huge table.
Oh yeah,
Yeah.
well, a huge set of tables, 3,000 decision tables all linked together to
Ah,
implement what in most rule systems would be 30,000 rules. Very, very lightweight, tuned completely to what the state of Texas and Mi- Michigan and New Mexico, those are the states that run this rules engine. It's tuned to their needs. And all that background in low level compilers and interpreters and whatnot uh, did me uh, it put me in good stead to understand the blockchain and the needs for implementing uh, logic on the blockchain. Factum was a little different than Ethereum. Ethereum is about doing computation in the blockchain, and uh, the philosophy that we had at the time was to secure the data and put the smart contracts and functionality in the second layer. and use the data layer as the basis for computation. The advantages of our approach have become very clear in Ethereum, that basically computation doesn't scale on chain, and you see that reflected in the Ethereum gas fees. And every other smart contracting platform that eventually gets to that critical mass of utility and use, they also suffer gas fee issues, because it's just expensive for all the nodes in a blockchain to reproduce uh, rerun the code and reproduce the results of smart contracts in order to validate their state. So anyway, we accumulate is the reformulation of Factum, adding digital identity and URL addressing to the blockchain, and that's what we're here to talk about.
I'm still a bit curious more about like the what you did for the state of Texas,
Yeah,
the rules engine. Yeah, so that sounds quite interesting. So did you write that program all by yourself, or like was there a
yeah.
team behind it? Or
So what
yeah.
happened was the state of Texas had a handbook, and it's a great big thick pile of policy, and they
Hmm.
expected state workers, prior to um, the work I did, they expected state workers to basically understand all those rules that were in the handbook and apply them to anybody coming in to apply for assistance programs. And it is incredibly difficult for state workers to grok the entire policy handbook and
I
apply
bet.
it evenly to everyone that walks in the door. And they were getting hit by the feds because they weren't getting consistent results for everyone that applied. So what they did is they took that handbook and they had a consulting firm generate decision tables, which laid out all the tests in basically in a chart, all the tests that they were, or questions effectively, that they were asking of applicants, and whether the results of the tests in a table, yes, no type of grid. And then they had X's that when these conditions are met, you should do this, and an X over here if you should do that. And then on the left, so you just kind of have a quadrant on the left, the actions to take, which might be ask more questions or evaluate more data until they came to a conclusion whether the applicant was um, qualified for those assistance programs. Now, since they had generated at the time about 2,000 decision tables, and I was brought in to tell the Texas how to implement the system, I looked at the tables and I said, I can write a compiler that will take your tests and take your actions and compile that into code. And if you do it this way, then you're going to guarantee that the resulting system does exactly what the handbook says. You won't be It won't be dependent upon developers understanding your policy and writing the right code. It'll simply suck in this representation and create a system that will evaluate your policy. And to the implementers, and at the time this was uh, uh, help me, it became CGI. What was it before CGI? Jay, you
AMS,
were involved with this
AM,
project. AMS,
AMS.
AMS, yes, yeah, and and their benefit was there would be no question that the code was right because we'd be literally executing this specification. And there were a lot of doubters. They didn't think we could do this, but we were able to throw it together very, very quickly. Deloitte came in as the um, implementer of the system. AMS was the company tagged to build the specifications and all the documentation behind the system. Deloitte came in, they worked for 6 months, they were way behind. They sucked me in from AMS as a consultant, and in 3 months we got the eligibility determination implementation. We got that ahead of schedule instead of behind schedule. And furthermore,
It's awesome.
they had figured it would take the largest development effort would be to implement all the rules, and so they had budgeted for the largest team of 6 different teams. They had a database team and a bunch of other teams, UI team, and all that sort of stuff, around eligibility. We were supposed to be the biggest team. We ended up being the smallest team they had, and we were supposed to be the team that delayed the project if anybody did, and we were always ahead. So that rules engine was massively uh, effective. And by the way, that technology, I ended up rewriting it to make it open source because it was not really open source under Texas. That technology is being used now by a company called C3 to evaluate regulations around crypto.
Awesome. Wow, interesting. I did not know that what you did now actually have impact even in the crypto world as well too.
Yeah,
Yeah.
we brought it over to
Yeah.
crypto, and we do have the idea that we should be able to integrate this rules engine mechanism with accumulate, and we'd be able, in that case, we would be able to execute massive rule sets against a blockchain with hardly any gas fees.
That's really awesome. So, by the way, for those rules book, right? What happened if there's one of the law or anything, maybe like eligibility change for a welfare recipient?
Right.
Do you have to maybe rewrite, update it, right?
Yeah, and that this is the big
Yeah.
advantage. You can go to the decision tables, and the subject matter experts can update the decision tables, and they don't have to directly involve the developers. So the management of the rules becomes cheaper, faster, more efficient, easier to manage. And in fact, it's been so effective for Texas. Uh, the rules engine has survived over 20 years, despite being a relatively custom implementation. It survived against all of the commercial products because the commercial products didn't stand up. They love the rules engine. It has worked so well for the state of Texas.
Yeah. In case it's not
Impressive feat right there.
yeah, in
Yeah.
case it's not clear that one of the when Paul's talking about those decision tables, he's just talking about Excel spreadsheets. Those are just
Yeah,
Excel spreadsheets that the state workers who are not programmers, they're just rule subject matter experts. They update spreadsheets, and this system executes the spreadsheets, and which means, for example, like managing the rules and versions of rules becomes really easy because all you're doing is managing versions of spreadsheets in a version control system. And so really their entire management of the entire process is a version control system and spreadsheets. And that's it
right.
to all
And
of
that
the
was
most
one of the
complex
that
federal government rules. Go
right.
ahead.
And that was one of the big selling points because most of the commercial products have their own rules databases, and they really need their
Mm.
own rules databases because the complexity of a typical rules engine. And then you have a hard time coordinating updates of policy with updates to UI and updates to the database and other updates to interfaces. All of those other things become very, very hard to coordinate if you don't have a single common source base that everybody is working against, the policy people
Yeah.
as well as the interface people, well as the database people. Now, we in software development, I'll just leave it at this summary, we've figured out how to use Git. We've figured out how to manage versions and having versions of the code that you can deploy in test environments and beat it out. But if you've got something that runs as an exception, like a rules database, it all falls apart. And so, anyway, that the whole idea that we have as a principle in the accumulate network and in all this development of how you might be able to execute rules on top of a data layer is keeping it really simple, leveraging all of the existing infrastructure that we have for software development and integration with systems, and make it work consistently and easy with the world. And most blockchains struggle with that interface to the real world. That's the whole um, value proposition of Chainlink, is how to link the world to Ethereum and other blockchains. So we're just trying to make it easier.
Yes, yeah, that's true. Fascinating. I think yeah, that'll make a perfect segue into the accumulate network what you guys are building at the moment. Maybe Paul, if you can give a quick background, like history of what was a problem you're trying to solve, and what brought you to create accumulate network, and then after that, maybe Jay and Paul, feel free to share any presentation or
Sure.
deck or website. Yeah, yeah,
So one of the things about the blockchain is it's difficult. Blockchains in general are difficult to interface with, as when you're running software from computer programs, as well as difficult from the human perspective. Looking at Etherscan for a newbie is baffling. It's just
yeah.
it's a bunch of numbers and contract IDs. I mean, even today, tons and tons of ether is lost by sending ETH to contract IDs instead of a EOA or the proper interface in a smart contract, um, because it's just baffling. So what we did was we took the security layer of the blockchain out of the addressing. In other words, with a typical blockchain, if a address holds tokens, that address specifies the security for those tokens. And what we did was create a honest account, and tied to the account is the security. And it gives us two big advantages. One, it means that I can specify the account with a URL. The world is trained on URLs now. We all understand how you click a URL and go and look at something, right? Um,
Yes,
but
yeah.
if you've taken the security out of the addressing of the blockchain, it means you can just take a URL and go somewhere in the blockchain and see what you want to see there, whether it's a balance of an account or something more complex. Um, the security then is itself an account, and that security account, which we call keybooks, are connected to uh, the accounts that they're going to provide the security for. So if you have a token account, that token account specifies a key book. Now that means that if you have a place where you're sending tokens and receiving tokens, like let's say you're an exchange, then your security of that account can be updated without you having to tell everybody that there's a new address. Okay. So you have the ability to manage that security. Then the key books also have the ability to allow multiple people to participate in the authorization of transactions. So authorizations of transactions against that token account. So you could have a token account that is a single SIG, and you can decide, oh, I need 3 people to sign, and update it to 3 people. And it's completely transparent to anyone who's sending tokens. Like in my original example, in an exchange, if I'm sending tokens to an exchange, it's completely transparent that the security has been updated. And if somebody leaves your project, then you can remove their key and replace it with their successor, whoever's going to pick up that role. Or if you decide you're going to eliminate that role, you can eliminate that role. So this just makes the blockchain act like everything people are familiar with already. If it sounds like the internet, it's because it was purposely designed to be like the internet. We want Accumulate to be a honest first level protocol like HTTPS and HTTP. It's designed to be able to fit into the internet so that you can seamlessly move from a browser into some part of the of the accumulate network, and from that accumulate network seamlessly move it into web applications and servers that are providing whatever functions they may be providing based off of accumulate or based off of real world applications.
I see. Yeah, interesting. So basically, like a somewhat similar to like a gateway, right?
Right.
Bring Web 2 user, yeah,
Well, I mean, a
to the
gateway,
blockchain
like
world.
you know how
Yeah.
when you're browsing, some system like Amazon, you have no idea as you click links what subsystem you are moving to or moving from. You from the same Amazon interface, you could end up in the Kindle world, or you could end up in the marketplace world, or in a video world. Uh, You don't know and you don't care. You click links and you go where
Yeah.
you need to go. That's what the way the blockchain and the whole crypto sector needs to work, as well as the security for all those things. All those things get
Hmm.
security updates all day, and it never impacts the user. And we need that kind of attention to the needs of those that provide information on the blockchain, or tokens or applications, the needs of those people as well as the needs of the users that are trying to use these systems.
I see. Yeah, that makes sense. I think that sounds very intuitive, actually. It's just
Yeah.
abstract away a lot of the complexity of the technology, but also providing the allowing the security to update at any time and all time, right? Yeah.
And all based on
Mm.
URLs. So once you
Yeah.
have a URL to something, it works even if it radically changes underneath it all.
Nice. So URL will be like a username in a way.
Mm-hmm.
Mm, fair way. Okay. I see. Cool. Yeah, and yeah, feel free to share your presentation, Jay. I think you might have, or we can. Yeah.
Yeah, the mute button and I have had a long and difficult relationship over the years. But let me walk through a quick presentation on the Accumulate blockchain. Uh, and first of all, the Accumulate is we're not just another EVM platform or another Bitcoin clone. Most of the blockchains out there are either Bitcoin or Ethereum with some glitter added in a lot of reasons, in a lot of ways. Whereas Accumulate is something completely different, written from the ground up, completely different. And rather than focusing on smart contracts, we're focusing on organizing data and authority around and underneath identities. And this fits the world model very well in that the world is organizations and people and the authority among them. So we're first of all organized around identities, and these identities are not represented by hexadecimal accounts, which are not very useful if you're trying to organize your world. Uh, Having a big long hexadecimal number doesn't help you a lot. Is this hexadecimal number a bank account? Is it a person? Is it I don't know what it is. Uh, Rather than that, the addressing in Accumulate is via uh, human readable URLs. You've got things like bank slash D slash accounts, bank slash D slash investments. So your naming structure and the fact that you've got internet-like domains allows you to quickly organize things so that you can sit there in a wallet and see something like bank slash Ethereum slash assets and bank slash token or Tezos slash assets. You can organize your world. And because we're identity based and identities can hold identities, everything's organized around identities. And when you look at the blockchain, you see a list of identities. It's hierarchical. So I can have identities that hold identities that hold identities, which means we're a chain of chains, and you can have subnets And for example, and one of the more interesting things is because the security rules are and security policies and such are defined at the identity levels. Some of your subnets can have different rules, which allows for some very interesting things. In um, Typically, blockchains are categorized as either a private blockchain or a public blockchain. You got to be one or the other. But in Accumulate's case, that's not true. You can be both a private blockchain and a public blockchain at the same time. For example, you can have a private blockchain, a subset, a subnet of the overall blockchain that is anchoring cryptographic proofs into a public blockchain above it, in which case you can have a private permission blockchain that I can still prove any data out of that blockchain to someone outside the consortium that's running the blockchain. And that's really unique and it's really powerful because it moves, one of the big complaints about private blockchains is you're not really much different than a distributed database, particularly if you're not part of the group running it. I mean, anybody outside can't trust the data because the group inside
Yeah.
can change it. In our case, we solved that problem. Uh, we talked about identities. So our identities and everything in Accumulate is it's kind of list oriented, lists of identities, and within the identities, um, their list. Um, as I said, the security model is upgradable. And when I say upgradable, it's your security model is basically parametric. I can go in and upgrade my security model later on. For example, at some point when uh, quantum uh, uh, quantum becomes quantum attacks, quantum computing becomes a problem, we can upgrade the security model and do it a part of the blockchain at a time. Um, what this does and the benefits this gives is things like security best practices like key rotation, key recovery. These are all easily supportable. The security models can match your business. So often when you're trying to write applications, you're trying to solve problems around a blockchain, a great deal of the effort is trying to mold the blockchain to the problem. And we go the other way around in that the blockchain fits into the problem. I don't have to write a lot of code that tells me that this particular hexadecimal address is a bank account. It can be obvious in the system. So, and the fact that we provide this hierarchical identity based model means that we can reflect the real world. When you build your identities and you build your roles, you can build them to be reflective of the real world. Again, this shortens the distance between what you're trying to develop and the problem that you're trying to actually solve, making it easier to develop code, cheaper to develop code, quicker to develop solutions, and ultimately the solutions are a lot less brittle with a lot lower total cost of ownership because they more closely match the problem they're trying to solve. Uh, and that's pretty much
In,
the overview of the protocol.
Interesting. Could you go back to the previous slide real quick? Just
I
curious. So I think you said
yeah.
like mimic the real world. Yeah, just one slide before.
Yep.
Um, where it's like a hierarchical structure, right? Like I think it was slide number 6. Yeah, this one. You said it's like ties, authority, roles, and identity. So for in this slide, for example, would each of the key, I guess, be associated to one of the person or
Well,
user?
yeah, let me give you a specific example here. So, if
Sure.
so, I've got in my executive director, Sue Gardner, uh, and she would have an identity on the system, and she would have keys on the system, sets of keys, and one of the things you can do is you can delegate your keys. So I've got somebody else, the CTO, and a developer, Brian, who's on the system. the executive director can delegate certain authorities, and you can create an identity that is a role. So the executive director, I can create a role that is the CTO role or a developer role, whatever I want. And then I can assign Brian Weber to that role. Sue Gardner can delegate authority to that role, and the fact that Brian is now assigned to that role gives him that authority. I give a real simple, very simple example of where this is valuable. Um, we recently had a case where we wanted to give some tokens to some investors. This is a really simple example and normally in the normal world, in Bitcoin, Ethereum, if I want to give tokens to somebody, I have to send them the tokens. I can't just give them the account that the tokens exist in, because there's only one private key. If I give them the private key, well, I still have the private key, and so they're not going to feel very safe. In our world, I can put the tokens in that account, and I can ask them, give me a key. And when they give me a key, I put their key in the key book that's in charge of this account. And now I tell them, okay, take my key out. And they take my key out, and now they have sole control of that account. And a really good example of where this would be valuable is if you think about FTX. And we have a way to prevent that, because normally, like if I'm working with Coinbase, I have to send my tokens to Coinbase, and they go to some Coinbase account, and I have no idea where they are. Our model would allow you to put your tokens in an account and then give Coinbase control of that account. So now Coinbase has your tokens in an account. They have control of it so they can do what they need to do, but you can see your tokens sitting there in that account. And if anything happens to those tokens that are your tokens, you can see them. Those exact tokens that they are controlling for you, you can see them. And if they use them to go do bets like FTX was doing on things, you can go, hey, where are my tokens? I didn't give you an order to do anything with those tokens. And this is possible because of this ability to set up complex relationships between the accounts, the identities, and the keys.
I see. Yeah, I think that makes sense. Interesting. So you can do very granular permission.
Right.
Go for it.
And so there's some privacy aspect here too, because when a key gets updated, you don't necessarily know who holds that key. And so you can have a structure that shows you what the relationships are between various accounts and whatnot, but you don't necessarily know who controls those accounts. And so the parties that are involved know who holds what keys, but but the analysis processes cannot see who holds those keys. And so it's complicated in some sense, but it's a way that groups like FTX can show some transparency as to what they're doing without showing who they are doing it for or who they're doing it with. And so the participants can see what their role is, but nobody else can really see. So there's just a massive amount of power that's completely unexplored in the blockchain when you make just one little change, which is separating the security from the account. Once the account is not the security, but rather holds a link to that security, then there's all this stuff that you can do. And we're just beginning to explore all the things that fall out of this decision.
I see. Yeah, interesting. Yeah, I think it sounds like a very potential valid use case right there that could potentially work. Yeah, we're talking about like use case. I'm actually curious, like who would be your intended users? Would this be more like businesses or individuals? And then maybe if you could deep dive more on like the personnel, the types.
Yeah.
the ideal profile, something like that. Yeah.
Well, I think you have
Mm.
to target everyone or it's not terribly worthwhile. It needs to be something that businesses can use, and it needs to be something that individuals can use in order to access the businesses. uh, and if it only helps the users, well, then the businesses aren't interested. If it only helps the businesses, the users aren't interested. So it needs to be something that solves some general use cases. Now, we haven't talked a lot, but but one of the designs around Accumulate is the ability to create very small cryptographic proofs and hand them to other blockchains and allow those blockchains to evaluate those proofs. And this allows us to provide accounts in Accumulate that actually control smart contracts in Ethereum or Cardano or Polkadot or Polygon or Avalanche, whatever, Solana, whatever your other platform is, and that means that you can have accounts all over the crypto sector and be able to manage those accounts from within Accumulate, where we're not suffering the gas fees. And we also have this mechanism to scale because of the way we've shard transactions. The Accumulate network is actually a network of networks. Uh, and the name Accumulate comes from the fact that we use a validator accumulator architecture. In other words, parts of the blockchain accumulate transactions and data, and uh, and well, I should say it this way: we have nodes in the system that validate blockchain transactions, and interact with other blockchains, and the cryptographic state of those nodes are accumulated into a network state. And this architecture allows us to run multiple networks uh, and allows us to spawn new networks as the Accumulate network grows, so that there's never this overloading that we see in Ethereum, and there's no hard limit where all the nodes have to understand everything. In other words, the validators have to understand everything within their domain, but the cryptographic proofs can be accumulated into a um, summary hash of the state of the entire network and progress forward. So I'm not sure that was as coherent as it needs to be.
Yeah.
The
I,
So,
real
I,
answer is, in order for you
mm,
to make a blockchain scalable, you have to have a cryptographic proof of only the data that you need. If you don't have a way of proving your data set independent of what everybody else is doing, then in order to have a full security of Ethereum, you have to run an entire Ethereum node, which is terabytes and terabytes of data, and it's just too big. In our
yeah.
system, we have created this architecture where the proofs of particular data sets are accumulated together into a small security chain that can then turn around and prove all the data that's in a particular data set without involving any of the rest of the blockchain. And so
I, I,
that that validator accumulator architecture is the key.
Mm.
yeah, and a
Go ahead,
specific
Jay.
benefit of that, well, I was going to say, and a specific benefit of that is, for example, I can run an entire node on a smartphone. If I load a smartphone with the entire proof set, which is the what proves the data, and then the data that I'm interested in, because I don't have to carry the data I'm not interested in, I can carry a smartphone around that then I can do transactions against right there on the smartphone, just as you'd be doing transactions on an Ethereum node. But I don't need terabytes to do it. Um, and we started this discussion with what Paul was talking about how we create small proofs that can interact with other blockchains. I give you a good example of that. One of our partners is doing in Invenium. Their business model requires them to do blockchain transactions on lots of different blockchains for their customers, which means they have to pay fees. And Invenium would really rather their customers pay the fees for the transactions they're doing for them. But in order to do that, you have to have an account. And so that if the customers were going to put an account on the Invenium platform, they would have to give Invenium the private key. And then the regulators said, well, then you're a custodian. And being a custodian is really bad because there's all kinds of regulatory consequences. So Invenium built this really cool thing where they'd encrypted the private keys and they kept them in a HashiCorp thing, and nobody at Invenium would have access to the private keys except maybe some DevOps people who might could do it. And then the regulators said, no, sorry, you're still a custodian. And so they came to us, and we've provided them a way where they're creating basically Ethereum abstract accounts, but where the account is really a smart contract that's acting like an account. But instead of putting the security as smart contract code, like the typical Ethereum abstract account, we're taking the security part of it and moving that out into Accumulate, which is designed specifically to do this, so that every one of these, like if I've got an Ethereum abstract account, it's tied to an Accumulate identity. And so now those Accumulate, the key books that we were talking about are now controlling that Ethereum abstract account. So the end result being, now the customer has an abstract account. They have their private keys, but they can delegate, because Accumulate allows this, they can delegate authority with their private keys to the keys of someone else. So they can delegate authority. The customer delegates authority to someone in Invenium. So now someone in Invenium can sign a transaction, but they're not using the customer's private keys. Nobody at Invenium has access to any of the customer's private keys. And so now all of a sudden they can do what they want. And this is a really widely a common use case. So now they can do transactions. They're not using the customer's private keys, so they're not a custodian, so they don't come all those onerous regulations. And that's only possible because we can do this little trick where we can create these little proofs, and what's happening is the abstract accounts just won't do anything unless they get a proof from the Invenium side that says, yes, I have authority over the identity that's associated with this account. And so now, now that you can do things like when somebody leaves the company and somebody else comes into that role, then you just take their key out and put the new key in, as opposed to, if you think about how it would work now, if I had Ethereum and the typical accounts, I'd have to go and take everything out of all those accounts, create all new accounts when there's a new employee, because there's no way for me to take the private keys away from the old employee. So we solve all of that problem, and we solve it not only for us, but we solve it for all the other blockchains. And that's kind of the point, is our whole reason for existence is to allow, because we're not saying smart contracts are bad. So in fact, we're saying smart contract platforms are incredible. They're one of the greatest inventions of the last decade or so. Trillions of dollars of value have been created from smart contract platforms. However, the model has limitations. There are a lot of things that it can't do, and Accumulate was designed to fill in those limitations and allow these smart contract platforms to reach their full potential, to do all the things that they can't do.
I like that. Yeah, I like the analogy you put. For an employee that maybe like leaving a company, then it'd be pretty easy to maybe transfer his or her assets over to like the new employee, right?
Hmm.
Seems like a very intuitive way to do. So I feel like maybe probably be good use case for like a companies, right? Maybe an organization with like the hierarchical structure, like you said earlier.
Hmm.
Then I think that would probably make sense, and you can give the roles and different type of permissions. Is that correct?
Hmm.
Different permission
Yeah.
for different people. Okay,
Yeah. The permissions to use
interesting.
the
Yeah,
assets
I
or to run smart contracts. One of the smart
mm,
contracts, because of the way they're built, I can only run a smart contract within an ecosystem, right? If I'm doing an Ethereum, I can call other Ethereum smart contracts, and I can kind of build a more complex program by calling other Ethereum smart contracts. But I just kind of have to keep building a bigger and bigger and bigger program. And from a software engineering point of view, it's exactly the wrong way to do things, because you want to have lots of small, simple, easy to test, easy to understand programs interacting. And the smart contract model basically makes that impossible. You just have to build bigger programs, which is why, for example, in 2022, I think there was $2.8 billion in bridge hacks, which is not surprising because a bridge is a gigantic, really complex, probably the most complex pile of smart contracts in existence. And surprise, surprise, they tend to have a lot of bugs. One of the things you can do with Accumulate, with this ability to use these small proofs to orchestrate things, is I can build in such a way that I have lots of small smart contracts interacting together to get something done, and they don't even have to be on the same blockchain. And this is kind of where I started, is in most blockchains you're kind of stuck. You can only work within that blockchain, but using Accumulate, I can orchestrate a bunch of small smart contracts across lots of blockchains to get something done, which basic software engineering best practices. This is how you build systems. You make small programs, easy to test. You build things in layers. I've got an application layer, and I've got a data layer under that. But if you think of the smart contract model, the basic way that it's designed, the data gets stuck inside the smart contract. So if I have two or three smart contracts, the data's in the smart contract. So how does that work between them? Where we allow the data to be in a blockchain layer underneath. And a specific example where that could be useful is if I have a security token that represents, I've taken, a commercial property, and I've tokenized it. And, real world asset tokenization, this is the next big thing. But so now I have these tokens that represent this, and these tokens are really smart contracts on Ethereum or on Solana or on Avalanche. But because in the smart contract model, the data which defines what that token is inside the contract. So if I have, say, an Ethereum token that represents my interest in this project, the security token, and I want to offer it on a Solana marketplace, well, that's really difficult because the smart contract is running on Ethereum, and the data is inside the smart contract. So that's really a problem. I mean, I can wrap it, but back to $2.9 billion in hacks on bridges, which I use a bridge to wrap it. So that's not a good. Whereas the typical best practices, smart or engineering practice, is to take that data and put it in a data layer, and that's what we say, is so that I can build smart contracts that implement the securities rules, but the data that says what this particular token is in accumulate below, so that I can instantiate here's that smart contract implementing the rules in a marketplace on Ethereum, and here connected to the same data is that smart contract on Solana and on Tezos. And the advantage to that is the whole purpose to do real world tokenization, real world asset tokenization. The big thing to the why it's good is because it allows you access to more liquidity. But if you can only be on one marketplace at a time, how is that going to improve your liquidity? To improve your liquidity, you need a way to
Yeah,
be on lots of marketplaces, and
it's
that's
very,
one of the things
it's
we
very
provide.
limiting.
Yeah, and
Mm,
I'm sorry, I got carried away. I love the technology.
I see. Oh, good. Yeah, no, I think that's a very good way to explain it. Yeah, I mean, it sounds like well, your blockchain. I mean, if what you say is correct, then you have solved the, I guess, the share liquidity or unify liquidity type of problem, right? For many other people who use it. That's great. Yeah, and also with the layer. Interesting. Can you maybe I know that most of the big blockchain, layer one, layer two right now. I think the main um, business model, as far as I'm kind of aware of, is like they provide like it's like the whole big playground or like the whole place where dApps can build solution on there, right? But dApps can build solution, and then from there they approach the consumer. I'm wondering like what is like where are you guys what sort of approach are you guys approaching it from? Or are you also approaching a lot of businesses and businesses you want build on top of you guys, and from there, approaching the end user? Is that a good way to think about it? Oh.
Well, I mean, we are right now focusing on approaching the end user.
Hmm.
There, like any blockchain, you have to build up a user base, and then you can build up applications, and then that'll help you build more user base and so forth. And so, right now, the focus is a lot on the user base, and at the same time, we're working with a number of entities like Invenium and others that to build applications that are running on Accumulate. So, a lot of our conversations with people uh, boil down to, oh, we can do this on Accumulate. We can't really effectively do this anywhere else. And so, especially involving identity and especially involving interactions with the real world.
Which is
Yeah, that's great. Yeah, sounds like
one of the reasons why
power.
we like podcasts like this is because we are so different. We're not like I'm not aware of any other blockchain that is like anything like us. And if you sit down with somebody and talk about that is another Ethereum like smart contract platform, they kind of already know what that is, and they know what to do with it, and kind of know what the limitations are. Whereas, we're basically coming and saying, well, all these things that you can't do with a blockchain, well, you can. But so we start with a communications deficit right at the beginning, in that a lot of the things we're talking about, most people will go, you can't do that with a blockchain.
I see. Yeah, but then for what you are building, then it's most likely possible in some way,
Right.
right? Okay. How many people currently in your team right now? Yeah.
Yeah, inside of IDD Labs and outside of IDD Labs, probably it's a fairly small group, maybe 10 or 15 people. Is that fair, Jay?
Yeah. So we're not one of the larger protocols. We're kind of a niche because we're very focused on data and identity, which is kind of in a niche. But
Yeah.
we're in a niche that's very needed. We're the little
I
animal
see.
perfectly suited to our niche.
Yeah, I think 10, 15 is still pretty good size. So with that, I mean, what are some of the challenges that you guys are facing at the moment? Because what you're building seems to be very unique and different, right? Yeah, so I'm
I
kind of
think
curious, like, what are
the
some of
biggest
the
challenge
hurdles?
is just uh, uh, recognition and knowledge of it. We haven't had the we when we launched Accumulate, it was we were talking about FTX a little while ago. We launched Accumulate, the hard fork from a fact, and the rebranding to Accumulate right before FTX, and so we picked the worst possible time to launch, and so we didn't get uh, we didn't have nearly the opportunities and resources that we thought we were going to have at the time because the crypto winter hit so hard right then. And so now that we're back into a crypto spring or a crypto bull market, we're starting to push a lot to get more recognition of what we can do, what you do, and we've got companies like Infinium that are building this abstract account implementation that they're going to launch out in the world, which will be, solves that custody problem, but a lot of other problems. And so we're making steady head, and thank you for this because this is you're addressing probably our biggest problem is just name recognition and people recognizing that, oh, I can do that. I can take a token and put it on multiple protocols. I can have it on. There is a way. And so you're helping us get the message out that there's a solution to these problems. This weird blockchain accumulate.
Awesome. Yeah, no, I mean, I'm just trying to shine the light on
Yeah.
various things that's interesting in Web3 for sure. So for the user, I'm curious, like, do they need to have some sort of a wallet? Like, do you need to install wallet, or how do they? I mean, I remember you said earlier it's like an address, right? But do they?
Yeah, there is an
What is the?
accumulate. There's several,
Yeah.
actually several accumulate wallets, and yeah, you do need a wallet, and it's an identity wallet um, that uses the URLs that you can see them so that you're working in domains and URL accounts. Uh, and there's one well, actually two wallets out now, and there's um, another five wallets about to come out. There's going to be a specialized data wallet, a specialized identity wallet, specialized governance wallet, a general monster wallet that does everything, and one other. So yeah, it. One of the interesting things is because we're different, require different wallets, and all of these capabilities we have, like identity and use and human readable URLs and uh, the complex governance is really powerful, but it's different, and so it's a two-edged sword. Go
We
ahead.
should mention that we're working on a EtherScan integration as well.
Oh
One of the
yeah,
things that Accumulate can do is it can accept addresses in a Bitcoin format or Ethereum format or other formats as valid signatures in the protocol. But that also allows you to use EtherScan to go to the Accumulate browser and use EtherScan to sign transactions and to perform operations. So
I,
when that's done, it, you just use an Ethereum, an EtherScan account to and the browser to uh, look at query information, token balances, and things like that
yeah.
on Accumulate and sign transactions.
And I'm going to sign off and let Paul continue, but I have
Oh yeah,
a
yeah. I know
conflict.
you do have to run, but yeah. So
Thank you.
thank you for joining up until now, Jay. Yeah, great. I'm gonna keep chatting with Paul
Yeah,
a
great.
bit more now. Yeah,
Bye.
for sure. Thank you, Jay. Yeah, awesome. So I think that's really fascinating what you're building there. Can you share with us some of the interesting numbers, like any particular traction number of user or
Uh,
number of companies and things like that? Yeah, that you had
well, we
previously.
have
No.
all of the Factum users from the protocol that started from 2015. Um, some of those have maybe gone away, by selling on exchanges, and so consolidation of some accounts. But it becomes really hard to say how many users. Right now, I would say we've been running in stealth mode because we haven't had the resources to do the big push. And what we're doing right now is going through a bit of a reorganization, and we'll be deploying some resources and really hit the ground in the next 30 days, I suspect. And then we'll uh, uh, almost certainly drive up the usage and uh, the active user base. So right now, I wouldn't say that the active user base is very big. We anticipate
Mm,
some pretty rapid growth with some of the projects that get deployed here in
okay,
just a
cool,
very
cool.
little bit. We are a staking platform, and right now, people that stake tokens get about a 18% return on their tokens.
What token are you referring to? Is it
The
like your own native token?
Yeah, the native token of the Accumulate network is Acme.
Ah,
So
okay.
like Roadrunner.
Acme. Oh, like the yeah, yeah, yeah. I was just thinking about that too. Acme. Oh, okay.
Yeah, yeah,
Makes sense. Yeah,
yeah.
I remember that.
And Acme is supposed to be all encompassing, and it has
Hmm.
certain implications, all utility, and so you can stake your Acme, assuming that you have at least I think 10,000 Acme is the limit,
Okay,
and Acme is relatively affordable right now. I think the
I
price
see.
has been running at a penny. So uh,
Hmm.
the only exchange that we are running on is the MEXC, and as well as Uniswap and some of the distributed exchanges. It's the only centralized exchange. But one of our plans is to get on several centralized exchanges in the next 90 days, and then start onboarding a centralized exchange every month.
I see.
Yeah.
Yeah. Yeah, makes sense. I think earlier, I think you said this is way probably half an hour or something, but you said you also have like a validated nodes network, right?
Yeah.
Obviously, to help run the accumulate. So do these nodes they get rewards in the Acme token?
Yeah.
I suppose.
Well,
Yeah.
all
Okay.
the everyone has to stake tokens in order to play a role in the network, and they get a little bit greater reward for being a validator staker, as opposed to someone who's delegating their stake to one of the systems, one of the validator. So you have validator staking tokens, and as a user, you can delegate your tokens to one of those validators, and you get about 90% of the rewards. They get about a 10% bump on the rewards.
Makes sense. Yeah, I think that's a pretty common model. A lot of the proof of stake blockchain networks where they also have the user delegate to the
Right,
validators, and then validator just stake and secure the network. Okay,
right.
that is cool. I think earlier, I think it was Jay mentioned that also you since yours, and then you also mentioned your security of the blockchain network is upgradable, which I
Hmm.
find it pretty fascinating because I'm gonna probably leave a link up here for the previous episode 36 where I talked to Dr. Duncan Wong. He's actually building an quantum ready or like post
Right.
quantum blockchain world. Abelian Foundation. I don't know if you heard of them, but anyway, it's I mean, he said, I remember he said that like when the the quantum computer is strong enough, like when it reaches 10,000 qubits, that's a unit.
Yeah.
Qubits, I don't know if there's an equivalent units or not, but anyway, yeah, 10,000 qubits, and it will be able to crack the Bitcoin blockchain network, like cracking maybe the key or something like that. So uh, so I guess my question for you is: does your blockchain will be able to have a security strong enough for the post
Yeah.
quantum world?
There are two things about so. Uh, in my personal opinion, uh, most of the quantum threat is FUD. I believe that operational quantum computers that can break Bitcoin encryption is going to be one of these things like nuclear fusion. It'll be a few years out for decades. I believe that when quantum computers begin to have traction and they begin to be useful and start solving some problems, then we will see that. We will see those applications deployed, like we're seeing AI deployed today, right? And
Yeah.
AI does a lot of things, but could AI fake my interview with you? No, we're not there with AI.
No.
So what I'm
Yeah.
saying is, when we see quantum computing begin to do some interesting things, that's a long ways before it gets to the point where it can break Bitcoin encryption. Like, AI is a long ways from being able to fake me in this interview. Um, eh, so we'll have warning. Uh, so item one about quantum FUD is that it will not pop up and suddenly break everything. That
Right.
that is not true. Item two is, I believe it'll take a lot longer than people claim. Item three is that there's no indication that quantum computers will break hashes. They'll break potentially the elliptical curve cryptography. Okay, but
Yeah.
most of Bitcoin holding lots and lots of Bitcoin are in addresses that have never sent tokens to anyone, have never sent Bitcoin to any other address, and thus the elliptical curve behind that uh, address has not been revealed. So if you can't break hashes, you can't break the elliptical curve underneath it, because the elliptical curve is hidden under the hash.
Wait. Can you explain,
Okay,
maybe explain the reason why? Like,
all right.
if an address hasn't sent Bitcoin yet,
Right. So
elliptical curve.
understand
Yeah.
what a Bitcoin address is. A Bitcoin address is
Yeah.
not the public key. It's the hash of a
Yes.
public key. And when you
Mm.
spend your Bitcoin, you reveal the public key under the hash. Actually, you reveal the script under the hash. And so if I send Bitcoin to you in a brand new Bitcoin address you generate in your wallet, if I send Bitcoin to you, all you give me is the hash of your public key, effectively. Okay. So that means that even though you have the Bitcoin, because I sent it to your Bitcoin address, the public key is unknown to anybody. Nobody knows what the public key is. Now, once you decide to send a Bitcoin to me from that address, you have to reveal the public key in that transaction. And when the network hashes that public key and it sees that that matches the Bitcoin address, then it approves the transaction. See what I'm saying? So in
Yeah.
order to spend, you have to reveal the public key. At that point, when you have revealed the public key, a quantum computer can attack the underlying signature. Until you show up, until you give the public key to somebody, quantum computing cannot do anything. So
I
most of the
see.
Bitcoin value that's sitting on the Bitcoin blockchain is behind addresses that have never sent Bitcoin to anybody, and all of those addresses are going to be secure.
I see. Yeah. Is it because of have to do with the UT Hexo model of Bitcoin?
It has to do, well, it's actually has to do with the Bitcoin format, the address format.
Hmm.
And by the way, the address format Bitcoin uses is replicated by everybody. Even our signatures that we use inside of Accumulate are not public keys, they're hashes of public keys, because we want to make sure that that address uh, hides the public key until the user uses it, And when after the user uses it to send Bitcoin to somebody or Acme to somebody or whatever blockchain you're on, they have the
Yeah.
opportunity to change out that key and with a fresh key that's not been used by anybody.
Hmm.
And so, uh, if I were going to summarize it, even if you don't understand all the math that I hand waved at, I would say addresses come in two flavors: an address that holds coins that's never been used, and an address that holds coins that has been used. And if you're the latter, you could be attacked by quantum computing. If you're the former, a fresh address that's never been used, you cannot be attacked by quantum computing.
I see.
Okay. And so
Yeah.
the
Simple enough. Yeah.
vulnerability of QA, even once we get to the point where it can break elliptical curve security, cryptography, there is another level yet where QA quantum computing becomes powerful enough to attack caches, and that's if we're 5 years away from being able to break elliptical curve uh, cryptography, we're probably 50 to 500 years away from breaking hashes.
Hmm.
So all of the QA, I want to say QA, all of the quantum computing threat to crypto is going to come with warning signs before you have to worry about it. So our our strategy at Accumulate is to create a blockchain that largely ignores the quantum computing threat. However, it's upgradable so that the second that quantum computing threat becomes real, we can shift to quantum resistant signatures.
I see.
But see, in our system, you just swap out the signatures, right?
Hmm.
So it's an easy upgrade for everybody, and we can then change the defaults, and we can deprecate old signatures, and we can provide alerts and wallets for people to swap out their signatures, and it'll just be a click to do it. And otherwise, the user, since it doesn't change the addressing, and since it's simply an internal wallet thing, users will be able to upgrade and it won't impact their day-to-day life. It won't change where their tokens are held. It won't change anything that they actually interact.
I see. So it'll be, yeah, yeah. I like that aspect. Yeah. And if I remember correctly from the conversation I had with Duncan, he said like 2034 was probably like, so probably 10 years away for the 10,000 qubits, right? Yeah.
Yeah,
But anyway, I don't know.
but
Yeah.
there's a bigger bar after the 10,000 qubits, in
Hmm.
that once you have 10,000 qubits, you still have to build the software that actually does what you want it to do. You know, if you want
Hmm.
to break elliptical curve cryptography, then you have to build that algorithm to do that, right? Eh,
Like compatible with the quantum computer.
yeah, to make that
Hmm.
problem, let's put it this way, to phrase the problem such that the quantum computer can solve the problem. Eh,
Hmm.
Elliptical curve computing, you kind of see how it works, because you have a set of terms, and those set of terms will only be satisfied by the private key, right? And so
Yeah.
there's a certain set of bits that have to be set to make the terms work. And so you can imagine that your qubits have uh, a qubit for every bit in the solution, and somehow that feeds into a set of qubits that drives a match between the set of terms in the in the in a elliptical curve solution to the solution. Okay, I know that I'm I, I can't get into the math because then it gets even really weirder. If that sounded confusing, the real answer is so complex I don't really grok it. Okay,
Mm,
um, with a hash, understand that hashes are an iterative solution that runs code
yeah,
that results in something. How many qubits do you need to simulate the execution, arbitrary execution of code? That's a lot of state, where the state feeds into the state, feeds into the state, feeds into the state. That's why hashes are slow. That's why, and hashes are slow enough to create this whole proof of work thing that we have in Bitcoin, right?
yeah, yeah.
And one of the arguments is you'll be able to build a quantum computer that's 10,000 times faster than a conventional computer to compute a hash, right? A, bullcrap. But B, that machine is going to cost what, $1 million?
Maybe I'm not sure.
Hashing
Yeah,
hashing
probably.
for proof of work is about how much you have to spend to find a solution. If I
Yeah,
can take a 10,000 hashing machines and pit it against a quantum computer, my spend over for 10,000 machines is likely going to be cheaper than that really fast quantum computer that's 10,000 times faster. So you have to solve the power problem, and you have to solve the cost of your hardware problem. So just because you come up with a quantum computer that can create hashes faster doesn't mean a thing unless it can do it cheaper than a lot of conventional systems. And so so basically, the core analysis of the quantum computing threat in blockchains is, in my estimation, overblown, and it's FUD, and it's based off of people that they want to say something that makes people think there's a dire threat. And honestly, uh, I'm not going to be politically incorrect and list all the things where we're told we have a dire threat and it's all a bunch of crap because it serves a political purpose. But there's got to be about 5 or 6 things that we encounter daily where you're told something is terrible, it's going to end the world, it's horrible, you need to, you know, do whatever, and it's FUD and it's not true. And there's a grain
mm,
of truth. If there's not a grain of truth, then the FUD doesn't, the fear, uncertainty, and doubt doesn't work.
yeah.
Quantum
Uh,
computing is one of those things.
interesting.
So you need to build the ability to respond. I believe that. But I'm going to wait until I see the real threat before I invest massive amounts of money and resources to solve a problem that we don't necessarily have.
I see. Yeah, I think that's probably a good sound strategy, I would
Yeah.
say.
Yeah.
Yeah, wait until you see something happen, right? Yeah,
Yeah.
and I mean, if it's still 10 years out, then yeah.
Yeah, but
Mm.
understand, we are going to see applications of quantum computing long before it breaks cryptography. There's all kinds of things quantum computing can do that regular computing can't do. Like, for instance, calculating the optimal route between a large set of destinations. Regular
Mm.
computing can't do that. All regular computing can do is guesstimate a near optimal solution. It can't, it's an NP complete problem. Have, put enough data points into a routing problem, and conventional computing cannot find the answer. That that's applicable to all kinds of manufacturing problems, uh, chip layout problems, like what is the optimal routing of signals on a microprocessor that has billions of nodes. Okay, quantum computing is going to solve problems there. And we're going to see those problems solved long before they address breaking cryptography.
I see. Yeah, I think that'd be great too. I mean, of course, we want to see more of the good use case of quantum
Right.
computing, right? Yeah.
We want to see routing
Yeah.
being done better, right? And and the other thing we want to see is we want to see the threat before we invest massively.
Yeah. Yeah. That is true. Yeah, I think it. I mean, it makes sense. I mean, you have limited resource, obviously, for your company, and yeah,
Absolutely.
don't want to. Yeah. Okay. Cool. Cool.
And the
Yeah. So
other thing
actually,
is,
oh,
another observation is the longer we go before we implement the solution, the more we know about the solution to implement more effectively and optimally. It, anytime we solve a problem before the problem really exists, when we get to the problem, we realize our solution was crap and we have to redo it anyway. So,
mm,
you know, the longer, it's called lazy evaluation. Anytime you have a problem that is computationally complex in software, you want to wait until you have to solve the problem before you solve the problem, because anytime there's a chance that you can discover a route where you don't have to solve the problem, being lazy will improve your performance because you're never solving problems that don't actually materialize. So lazy evaluation, it works in your personal life, it works in your it works in technology, it works in addressing large existential threats, uh, because we never really know all the parameters of a problem until we actually see the problem. And so preemptive solutions are, generally speaking, wasteful and useless.
interesting. Yeah. Thank you for sharing that. I think I mean, I've read a few books on computer science, but I don't think I've. Maybe I've come across a term somewhere, but lazy evaluation.
You
I'm
will
gonna
in code
try to
optimization.
learn.
Code optimization
Oh,
is a
okay.
big place where you'll hear about and I told you I have a compiler background and interpreter background, and so
Oh,
lazy evaluation has been something that I have used repeatedly.
I see. Yeah, I remember from my CS back day. I think one of those was the greedy method or
Yeah,
something. Greedy algorithm. Yeah.
well, greedy
Maybe.
matching. Yeah,
Mm,
yeah,
yeah. Yeah. Fascinating. Anyway, yeah, I know there's a lot of things you can apply from the computer science world to the real world as well too.
right.
Yeah. Very fascinating. And anyway, going back to your company,
Hmm.
I'm still curious. So in the future, maybe if you have like a crystal ball, like where do you see your, yeah, what is like the, I guess, ideal end game for your blockchain network? Like where do you see it heading?
Well, I want to
How it will mess with the Web3 world? Yeah.
Sure. Well, one of the things that I believe is critical for blockchains is to address all of the use cases that we have been told about over and over and over again, um, that have not actually materialized. For example, supply chain. You know, IBM with Hyperledger Fabric and Walmart all did a bunch of stuff about creating a secure supply chain for some of their products, right? And there was a lot of fanfare 3, 4, 5 years ago in 2017, 18. You don't hear about it now because the solution didn't actually scale very well, and it was expensive and hard and difficult. Um, I want to accumulate to deal with supply chain problems. Okay. Uh, Tokenization has been one of those dreams that started in 2016, 2017, 2018. We wanted
Right.
tokenized securities and that sort of stuff. We still don't really have tokenized securities. Tokenization is struggling. It's
I
there.
think it's coming. I'm guessing it's coming. Yeah,
It
with
is
this
coming,
cycle. Yeah.
but it's been coming for
Yeah.
5 years. So, so I believe our architecture involves a lot of advantages for tokenization because we don't just create um, uh, we don't just create a smart contract that holds that can support certain types of tokenization, and oh, I need another one for another thing and another one for another thing and that sort of thing. What we do is we build a data platform and an ability to create tokens and the ability to build infrastructure to administer those tokens so that a single token type can act as simple as a representation of a movie ticket and cheap enough to be a movie ticket, all the way up to something that's as complex as some sort of vast security that involves, you know, uh, access controls to uh, infrastructure and resources and ownership and everything, some sort of conglomerate type of super token. You ought to be able to move seamlessly from a movie ticket all the way up the chain to the most complex tokenization you can imagine. And so we built an infrastructure for that, but we built it by creating URLs so that the token is always identifiable at any step of the game. We've built a infrastructure on token transactions that allow uh, management of how those tokens can be moved and how they're interpreted. And we've created the infrastructure to attach to that uh, the access controls, both on chain and off chain, to resources. And so that's I would like us to achieve what's possible around scaling transactions, being able to support the entire world and 9 billion people playing around with tokens. I want to create a world where your browser is all you need to see what's going on in the crypto space, certainly inside of Accumulate. But I would like to
Yeah.
build the infrastructure so that from Accumulate, you can look inside of Bitcoin and look inside of Ethereum and Polygon and anything else that exists out there, right? So I want to be the window. I would like it to create provenance of information. Today, you read something in the New York Times, or you see a
Yeah.
picture, there's no provenance. So you haven't any ability soon, you won't have any ability to tell the difference between an AI generated image and a real image. So we want to address that. So once you start getting into what the applications of managing data integrity is, there's just too many ways to apply that, too many problems to solve. And I would like to be in the middle of that solution.
I see. Interesting. Yeah, certainly. I mean, with the proliferation of AI, yeah, now it's probably certainly. I think there'll probably come a day where there'll be need. But I'm actually more curious about. I think you mentioned supply chain, right?
Yes,
Like why supply chain? I'm actually very curious about. Tokenization. I think makes sense. It's quite an obvious use case. Well, nowadays I think
right.
it's obvious. I think 7 years ago it was not. Yeah.
Well, I think supply chain is important in order to know that the products that you receive are legitimately the product that was developed or grown or created at some origin with
Mm,
some set of people, and being able to understand who was involved, understand who when it changes hands and suddenly becomes under new management, to be able to see all of that is pretty critical. So people are now concerned about the quality of their food. They're concerned about the ingredients of the things they're eating or they're bringing into their house, and they gain exposure to whatever uh, good or service that is. um, and we need that supply chain stuff. And then eh, and the supply chain problem is particularly difficult because, let's say you've got a product that's coming from, I don't know, South America somewhere. Okay, like let's say lumber. There's a lot of lumber that we
yeah.
only get from South America. You want to know who cut that lumber. You want to know where it was cut, whether it was cut under a legitimate registered uh, area with a registered logger versus someone who just went out someplace and stole some lumber off of public lands or uh, wherever. Because there's a lot of what you could call poaching of lumber that occurs. So you
Yeah.
want to know your lumber is not poached. I don't think that's the right term, but we
Yeah. I
understand.
know what you mean. Yeah.
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 And then you want to know who milled it. You need to know that it was properly exported out of the country, right? Because there is some concern about people that where that lumber goes into the black market and whatnot, and then it might have been substituted with something else, even though it claims that it was harvested at point A. It may have been harvested at point B. So you want to track it. And in that supply chain, it's very complex. You need to have each party that engages with that product at every point that it changes hands or every point that a process is applied. You want to be somebody to be able to join the supply chain process or be replaced out of the supply chain process dynamically as it moves. And so that that's a complex problem. And when
Yeah.
Hyperledger tried to do it, it was massively expensive because you can't just expect the next guy who has a boat to be on your system. It needs to be lightweight, right? I'm going to pick up this product. This product is tracked by a supply chain. Well, I don't really do it. You give the guy URL, he goes through some steps and he goes, "Okay, I'm done." Right? It has to be really lightweight with not a lot of infrastructure requirements. And then when it comes to the into customs, you need to be able the customs in the US needs to be able to understand that supply chain and be able to accept it. We actually had a contract under Factum to build these supply chains, coincidentally for lumber, coincidentally from South America largely. Okay. And we went through 2 layers of the contract, and we got and we had successful completions. Um, we had a resource issue that caused the reorganization of Factum, the company that became IDD Labs under Invenium, where they bought the assets and whatnot. But we lost that contract in that process. Uh, but but I have some experience in this, and it was going very, very well. Our identity solution is very powerful. Under Accumulate, it's even vastly more powerful because it under Factum, it was a second layer application to manage identities. Under Accumulate, it's a protocol supported feature, and that gives us more consistency. One of the things we learned with Factum is we needed protocol level identity in order for everybody to be interoperable no matter who they are. It's one of those things everybody needs to share.
I see. Yeah. We're saying that. Oh, actually, I'm gonna maybe play the hard guy here, the devil
Yeah, sure.
advocate here for a second. Yeah, but I didn't. One thing what about the well, for the supply chain is that, let's say, if it's lumber, right? You have maybe, I don't know, 1 ton of lumber, but
Hmm.
then suddenly somewhere along the way, maybe some of the lumber was swapped out, right? Maybe it could be
Right,
swapped out for the maybe cheap or the fake lumber. Maybe they could put rock or something, and I don't know.
right.
And then, so how would you track that on the blockchain? Like, yeah, it's like that's one.
Well, that is
Yeah.
true. So
Yeah.
there are a number of technologies that you would want to employ. You would want to employ anything from taking the weight of the lumber,
Mm.
which would be very, very, very difficult to replicate.
Yeah.
You there's some spectrometers that can take a measurement of the molecular signature of the lumber, which turns out to be very, very different from one batch of lumber to the next. Uh, there's a host of ways to ensure that the lumber itself at one point is the same lumber at another point. Um, the other thing that you're doing is you're getting everyone who touches the lumber is signing on and thus responsible for the supply chain. So anything as weird as somebody driving a nail into part of the lumber at the very beginning, where you prove
Yeah.
that that nail doesn't exist later, now you have the list of people that are responsible. So that allows you to hold people responsible, and they could get banned from being participating in the supply chain. So one of the one of the big things to do is ensure that that there's responsibility.
Yeah, going back to that lumber, I guess another question. I mean, maybe it's not lumber, maybe it could be another product, but is it really worth it to put a lot of these fancy technology, right? Into the cost of goods sold? If it's like just a commodity, so I guess, yeah. I mean, there's a certain cost limit, right? Because you can't just keep imposing like costs on that, because eventually, if as a business, you have to look at the whether it makes sense or not for the. So transportation logistic cost is just one of the costs, right, in the
Right,
whole, I guess, the life cycle of the wood, right? And I guess a blockchain or tracking supply is like an IT solution. I mean, I'm just looking at like the very big picture, right?
right,
It's like so I'm sure there's a limit, right? People are not gonna want to employ a fancy IoT with drone tracking twenty four
right,
seven
right, right, right,
camera
right.
on like some lumber. You know what I mean? Yeah.
No, no, no.
So probably not gonna
So
make sense. Yeah.
what you want to do is, like in the case of lumber, one of the reasons that it made
Mm,
it very cost effective is that if you were, and this was the plan. I don't know that it ever got deployed, but the plan was, if you cooperated in this supply chain system, then when you got to U.S. Customs, you'd slip right through. That they would be able to do a cryptographic assessment of the lumber and come to a certainty that uh, is otherwise very, very time consuming. So in their particular case, I don't remember the exact numbers, but it took like a week to 2 weeks to get through custom. In this case, it would take hours to get through custom.
oh,
So if you could save
nice.
that kind of time at that point into
Yeah.
your major market, then it is worth the expense. Honestly, if you produce nails and you want to import nails into the US, nobody cares about the substitution risk. The nails themselves are pretty easy to QA, right? And
Mm,
the manufacturer of the nails has nothing to gain by allowing somebody to swap out a poor quality product representing
that's
their
true.
ability to produce nails. I mean,
Yeah.
so this level of supply chain does not apply to every product. But if I'm talking about computer chips, I have friends
Mm,
who buy certified computer chips, you know true Intel parts, because their experience on the knockoffs is that they have bricked devices because the chips don't work, and for security reasons a lot of circuits will just brick the device to
yeah.
prevent compromising uh, the computer or whatever. And
Yeah.
they have bought what appeared to be Intel pro- parts over Abu Dhabi, and Abu Dhabi's not right. What's the Chinese market for manufacturers out of China?
The chips, you mean, or the pot?
No, no, no.
The
The
pot would be
the the
Shanghai.
market, the like Amazon. The Chinese version of
Oh,
Amazon.
Amazon. Taobao. I think Taobao is probably one of them.
Taobao might be one.
Taobao.
I don't.
Yeah.
There's one that
Yeah.
begins with A that you
Mm.
that I've bought products from. But
Alibaba.
Alibaba. That's what I'm saying.
Yeah.
And I said Abu Dhabi.
Yeah.
Alibaba. All right. He bought them through Alibaba, and then he protested that these chips were bad because his product, his circuit boards were being bricked because the chips were bad. And the merchant he bought it from said, no, 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 those are good. And Alibaba said, all right, we side with the merchant. And so he bought
Mm.
a relatively expensive batch of chips, and he was out of luck, right? And so
Oh.
having a supply chain to ensure that the legitimate chips make it all the way through becomes interesting. Whereas, because that's a fairly expensive part,
Yes.
there, you if you built these supply chains and the supply chains lose credibility because the part is provably not correct, then you have all the people that signed off along the way. You can identify who you want to be banned from the supply chain, and that hurts them. So now suddenly, and furthermore, if people are only accepting Intel chips from a supply chain uh, source, a supply chain based source, then there's nowhere for the counterfeiter to sell the legitimate parts, right? If you
Yeah.
remove the legitimate
Yeah.
parts and you risk being trashed because your parts are bad, then you've got to find a trashy end user that's willing to take your stolen parts, known stolen parts, because they're not in the supply chain. So it makes the whole uh, process of substituting bad parts difficult.
Yeah, certainly. Yeah, I mean the case for like chips, right? Any chip, which is a very expensive product, then I think the supply chain will totally make sense
Food,
for blockchain.
food.
Food, yeah, food. I guess depend on the type, right? Depend on the type.
Well,
Maybe
but
we
depending
have
on the
some
type, but a
different.
lot of people are
Yeah.
concerned that their food actually
Mm,
comes from uh, Fredericksburg for Fredericksburg peaches. That's a thing here in Austin. People really like
okay.
the Fredericksburg peaches, but those peaches can be swapped out for generic peaches, and generic peaches literally are not as good. There's something about these
Mm,
peaches, right? And organic food people, the people that are willing to
yeah.
pay the extra dollar a pound for their food to ensure that it's literally where it's supposed to come from, they're willing to pay that extra supply chain cost. Me, the budget guy, coming in and just getting eggs off the shelf, am I going to be worried about the egg supply chain? Probably not. You know why?
Yeah.
I'm
That's
already
true. But
paying for the egg that I want. Uh, I'm not going to pay more. So
yeah, certainly. So yeah, like you said, I think there's a market for those very high end, like maybe organic food. There's people who are willing to pay that. Then I guess the supply chain can absorb the extra cost of utilizing a blockchain solution, right?
yeah,
Yeah.
and if it's
So
cheap enough,
yeah.
you can start talking about videos. You can talk about
Mm,
cameras that log a hash on the blockchain, and you have you basically have proof that the image that you're looking at is the image that that device produced, right? And AI can't change it because if it changes it, it messes up the hash. Now, there are times when you want your photos or you know, um, your media edited and reformatted and improved, but the editor, formatter, improver can go on the blockchain and say, yes, these are the sources with the hashes that I used, and they can say, here are the hashes of my product that I've produced. And now, even though the image could go from a device to the New York Times to a paper, or well, papers don't work because they can't carry hashes, but to a
yeah.
media outlet for release, you can see the supply chain from the device through the editor to the result. And so and they did this with the Trump picture. Did you read this? Some of them, the one that had the American flag above him and he had his fist in the air.
Oh,
Some
yeah.
of the
Was that a real image, by the
yeah,
way?
that
That
was a
was a
real
real image,
image.
right?
That was a real image. There's actually
Yeah.
video of the photographer taking the picture. So the photographer
Really?
had a guy who was following him
To
around,
prove it.
filming him as he
Yeah.
took the pictures as proof that he was the one taking each of these pictures. and you have the video of him taking that picture because he came up under Trump and there was an American flag above, the
Yeah.
stage, and he managed to frame it with Trump and the American flag. But the point is the New York Times, or maybe it was CNN's, one of these groups edited out the American flag because
Hmm.
they didn't
Interesting.
want to have Trump, raising his fist in front of an American flag. They thought
Oh,
that was a step too far, and they edited it
I
out.
see.
So you should be able to see who took that image out so that you can ask them why, right? And
Yeah.
and the administration has even complained about what they call cheap fakes. You should be able to prove that video is real, that the video is in context, if that's what you care about. All that should be available to us. People need to learn to do their own due diligence about so much information because the media outlets have been caught lying way too much. And I'm not going to exempt. I'm not going to exempt Fox. I'm not going to exempt any of these people. Um,
Mm.
I could give examples, but it just becomes. I'm sorry, I shouldn't have even brought up Trump, except that's the only editing that has happened recently that I could point to. But
Oh,
editing has
yeah.
occurred a lot.
That is true. Yeah, I think now with like like I said earlier, the proliferation of AI generated images, it's gonna be harder and harder, right?
Yeah,
Like be able to tell, and I mean the technology is getting better, right? Obviously, so some of the image now generated, you can't even tell whether it's like a real person or like a fake person, right? You see a lady from an image generated by AI. Sometimes you think, oh, is this a real lady? Wow, she looks just like real person, but in the end, it's just an AI generated image. Yeah, so I think we do need some sort of technology to kind of distinguish between the real and the AI generated,
right,
because now it's like blending the two worlds, right? And then eventually it becomes quite scary for us, right? Because maybe some of the image you generated, you don't know what to believe anymore.
right,
Yeah.
absolutely.
Mm.
There's a very popular YouTuber um, that uh, oh, he recently, I want to say his name is Bento. I was trying to, while I was talking, try to look up and confirm that. Um, but in any case, he let me get his name, get it right. But let me tell you the
Sure.
story. So
Sure.
he was talking about how good uh, AI is getting at writing music, and
Mm.
there is a website um, where you can go, and I guess I won't give them advertising by saying who they were, because mostly because I can't remember the name of the website, but you can go there and you can say something like, uh, in the style of Joplin, uh, a ragtime, uh, happy and uplifting, and it will, piano only, and it will generate a piano piece that fits that description. And each time you hit it, because I played around with it a bit, each time you hit it, it would give you a different cuts. Uh,
Mm.
uh, yeah, Rick Beato, Beato. He did this video, and he could not tell the difference between a AI generated song and a song written by an actual person. And he just could
Wow.
not hear the difference. Could not. The song's playing, and he's like, I just don't hear it. But his son claimed that he could tell the difference and his wife could tell the difference. And so he
Hmm.
decided to do a test. He went and found some very he's quite the musician, right? So he found some very obscure music. He found some AI generated music that was of the same style and mixed the two, and tested his son and tested his wife, and they both scored 100%. They could identify the AI stuff and he couldn't. And he's the career guy who's been in music forever, right? And he had no
Fascinating.
explanation. But his son also said, I can hear it now, but I can imagine if they just make a little bit of an improvement, I won't be able to tell. And so this opens the door to AI providing your playlist based off of your preferences that has nothing to do with a band, has nothing to do with that whole industry. You could just listen all day to ragtime music if you liked. You could listen all day to blues, punk, hard rock, ballads, and this includes words and singers, right?
Yeah.
So at some point, creating the provenance of where this stuff is generated is going to be the selling point. It, Otherwise, it's just crap AI generated. And this is an existential question as to whether it's important that people create what you enjoy. I can imagine that here in not very long, you'll be able to say, I would like to see a sci-fi movie based off of Sleepless in Seattle. And the AI generates an entire 2-hour movie for you.
Yeah, that would be really fancy. Well, I feel like we probably still a bit far away from that, but it might come in the future, right?
Yeah, but but
I don't
but
think
but
we.
it may not be as
Yeah.
far. Or another application of AI is a movie studio can take the major actor of a series. Like for instance, look at Star Wars. We have we have Luke Skywalker. You've got Princess Leia. You have Obi-Wan Kenobi. You have all these actors. You cannot do another Star Wars movie with those people. You have to you have to decide, oh, movies are going to be done either before, prequels, or afterwards, because those people are in some cases dead, right?
Yeah. Yeah.
But if you did the movie with an AI character for the major actors, so you have a regular person who walks around, but the computer replaces him with the AI character, with the speech patterns, with all that, then you can make that series forever.
Yeah. I
And I've actually,
I think I've heard about some.
yeah,
Hmm,
I've actually
I
predicted
heard about
this
some sim.
for a long time.
Oh,
Yeah,
really? You
yeah,
did?
back in the 80s, I said, eventually uh, we'll be able to just generate the image, and that way the studios won't get uh, hung out to dry by a very popular series based off of, say, Robin Williams. That happened with Aladdin, right? I mean, they tried to go
Hmm.
without Robin Williams in the second Aladdin. No one ever watches the second Aladdin. That was a horrible flop. Um, uh, that sort of stuff. Yeah, it, businesses do not like to be held hostage to individuals.
No, that's true. But also, I mean, I guess individual do not like to be held hostage to, I don't know,
Businesses.
things that wouldn't restrict. Yeah, things that restrict freedom. Businesses. Right?
That's why I like open
Yeah.
source, because
Me too.
yeah,
Yeah.
so I wrote the rules engine for the state of Texas, right? But
Yeah.
it was not open source. It was what you call government open source, which means another government entity could ask for that software and Texas would be obligated
Hmm.
to provide it. Okay. But that was also laden with all kinds of burdensome uh,
Bureaucracy.
processes, yeah, bureaucracy. And so when I
Bureaucracy.
went to Ohio, they had such a hard time getting the rules engine. I had to rewrite the rules engine for Ohio. But then it became the
Oh
property of
man.
Ohio. And so
Hmm.
after I had written the rules engine twice, the third time I decided, well, I'm just going to write an open source version. So I wrote an open source version, and then I used that version for Maximus uh, and and whatnot. And uh, since it was open source, when I left Maximus, I no longer had to rewrite it. And so that opens the door for C3 to use that for crypto regulations. So open source is really critical for developers to be able to use software they develop in their career without it being held hostage to who they worked for. So this is one of the things that's very powerful about open source.
Absolutely. No, I completely agree. And I think that's what one of the powerful thing about the Web3 ecosystem or Web3 world that we live in. I think I would say 95% or even 97,
Hmm
98%
hmm
of the code in Web3 is like open source pretty much. It's even some of the best, you find open source library frameworks and all of that for allowing people to build one thing upon another. Composable, I think composability, interacting one another, which is really cool. I mean, we don't see that a lot in the Web2 world, right? For a lot of the enterprise code solution, they usually like closed source because obviously they want to be able to sell that for
Yeah,
some
and I
companies.
get
Yeah,
I get that companies want closed source, but one of the big powerful advantages of open source for companies, and it took them a long time to get here, right? But
yeah,
they now recognize that if they use open source like Linux or they use open source like SQL, then they have access to improvements that occur in the industry. And if it's not the core thing they're doing, then you know why would you want to do that work in house and try to keep your competitors away from it when the vast body of competitors are going to do a much better job than you can, you know? So, um,
yeah,
so this is why infrastructure is going open source across the board in the industry. Um, the other thing that happened in the blockchain is nobody's going to trust a blockchain that isn't open source. You want
hmm,
you want anyone to be able to look at your source code and do a survey of it, do a code review, and
yeah,
have that certified by a third party, and prove that the software you're running is the software that that underwent the audit, right? You can't
yeah,
do that if it's closed source. All you can do is say somebody audited my software. You just have to trust me. Nobody's going to buy that. Now look at the banking and financial system. None of that's audited. None of that's open source. You swipe your card at the grocery store. That whole process, that the supply chain between you and the guy that receives your dollars at the end has six companies between you. Do you trust that? Why do you trust that? No one should trust that. You know the 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 lack of integrity of data for really critical things like money is horrifying. And this is what the blockchain, this is what Accumulate is concerned about, is the fact that we're asked to trust people who repeatedly fail, like the SEC. There's no audit trail of what they did with the FTX. They approved them as a public company. They approved FTX as a public company allowed them to be listed on public stock exchanges, and they were running the company on QuickBooks. The failure was not crypto. The failure of FTX was Gensler, was the SEC, because FTX was donating money to politicians. It was
Yeah.
a corrupt political process. And they have successfully been able to say FTX is represented. This FTX proves that we need to regulate crypto more. No, it doesn't. It proves your own regulations, your own regulatory um, job title, your mandate was you ultimately failed. Anyway,
Hmm.
I hate to
Yeah.
go there, but look, we could talk about any corruption at all, and I can prove that basically it all boils down to the ability of people to lie, because nothing, some process that they're involved in has there is no proof that the process was correct. And
Yeah.
that the blockchain is the solution.
Yeah, certainly. And I mean, just thinking about even an individual company perspective, right? If they have an incentive or there's benefit for them to lie, then I don't see any reason why they wouldn't want to, right? And if it doesn't cost them anything too as well. So yeah, I do hope that we can use blockchain will be able to be that solution out there in the future. Um, anyway, I think we've actually had some really long and amazing
Yeah, yeah,
conversation.
yeah.
Gonbo accumulate Web3 and everything is really enjoyable actually. So I just want to ask maybe two more questions
Sure.
out of
Two
respect for
more
the time.
questions.
Yeah, two more questions. Yeah. So one is that do you have any advice for people who want to build their own Web3 company?
If you are a single issue voter, okay, so I don't want it to be political, but if you're a single issue voter, and you want Web3 with the blockchain and the crypto sector, then your only choice is Republicans this time around. The Democrats have 4 years of oppression. As somebody who's lived through the 4 years under, working on a blockchain underneath the current administration, it's been horrible. The attacks, the
Hmm.
risk, the extra legal costs, all of that has just been terrible. We've got to have a administration and government that's crypto friendly. Single issue. If there are other issues you care about more, your mileage will vary. But I think I'm on pretty solid ground when I say that we've had a very anti crypto um, administration in the U.S. and it's bigger than the U.S. The U.S. drives the entire world, and so all of the issues that the crypto sector has across the world with regulators, we can lay it at the door of the U.S. I mean, there's some Europeans that contribute to that. I mean, it's not completely the U.S., but the U.S. is the big gorilla about oppressive regulatory um, actions. And I also think that when it comes to Web3 and the internet, a free internet, uh, we have some real concerns about the private companies that are censoring content, and whether you're ultra liberal or ultra conservative, we're all harmed by censorship. And so I don't know what we do about that as far as a Web3 company. It, all these concerns. I think if you want an easy, straightforward, you don't have to worry about anything life, go get your job in a big major company and take your paycheck. If you want to be an innovator and you want to be an entrepreneur, uh, understand that it's going to be a hard, tough road. And
Hmm.
I think you should innovate. Obviously, I think you should integrate accumulate into your products, but uh, integrate in good tech, solve fundamental problems, keep it simple, and I think ultimately we win. I think ultimately uh, both parties in the U.S. are going to recognize that the crypto sector is critical to the economic future of the country, and they're going to come around to our way of looking at innovation. So, you know, keep expect the fight, keep a stiff upper chin, uh, and have faith that ultimately we will win. Because we have the we're about cryptographic honesty in processes. We're about making something that's true when you see it inside of a world that has AI threats, that has quantum computing threats. We're the sector that will create freedom. So, uh, I hope you feel good about your Web3 project. That's what I would say to them.
Oh, thank you. Yeah, I think that's very sound advice. And of course, I mean, my podcast is very neutral. I don't really advocate any politics here. And also, a lot of my listeners are also like from international as well too. So, but of course, like you said, I think U.S. is, especially U.S. politics now with the presidential election is coming up, and I think yeah, that will certainly have a big effect on crypto, whether we like it or not. So
Well,
anyway, I do hope
I
that there will be
I
a
want to I
solution.
want to be nonpartisan too. I don't want to be on the
Mm,
politics, but I do think that it is incredibly important, and we're actually seeing it in both parties that they're coming around to crypto,
mm.
largely because the crypto sector is beginning to donate, and they're not SBF. Okay,
Yes, correct, correct.
they're
Yeah,
beginning to donate. Um, that means the crypto sector is kind of buying its politicians the way everybody else buys their politicians. Uh,
yep,
uh, but I think that being sensitive to the issue, and and being, regardless of how you do it and to which party you do it, pushing for uh, a recognition that crypto is self-binding. The software creates the cryptographic proofs that prevent a large body of crimes that have occurred in the banking and financial sector through the centuries. Okay, so where we can code uh, fairness, where we can code anti uh, counterfeiting, where we can code security, we need to do that, and we need to recognize the crypto sector can solve problems that traditional implementations just can't. Okay, so I want to
yeah.
make this nonpartisan. I want you, I want us all to be single issue voters and beat up the people that we support to support the crypto sector, and to develop in the crypto sector. So the more solutions we have, the more political pressure we exert, the more reality and education that we can give the population, the quicker we get to this nirvana where things work um, cheaply, effectively. Like we were talking about, how can blockchain on the supply chain lower the cost of
Yeah,
products? It can, right? But it can only do that if we're allowed to innovate.
that is true. Yeah, I completely agree. I think for a lot of the builders and innovators in space, they just want like a fair playground, right? To build and to innovate. They don't really want to be like get involved in the politics or anything at all. But it just happened to be the case that politics is involved. Yeah, quite
Well,
sad. But anyway,
politics
I
and
mean,
money. The there
it is money. Yeah.
there are no countries. There ought to be a country every year that moves from a developing country to developed country. Every year there should be a country
Mm.
that does that. Since Japan, arguably Korea, no country has moved its status from developing into developed? Because the economic playing field is not level. Developing countries are handicapped, not aided by the banking and financial sector, worldwide financial sector. Crypto is a level playing field. Crypto provides the way for countries to settle debts, to make payments without paying more, without being subject to credit scores, and arbitrary sanctions and regulations that the regulations are a sort of sanction that nobody admits as a sanction. They just regulated out of the
Yeah.
market. Okay, we need to have a level playing field. If you have the ability to pay, you should be able to pay on the same terms as some entity out of the US or out of London, and crypto provides that. So world peace, world prosperity, all good things depend upon cryptographic proof, cryptographic truth.
Yeah, that's a very beautiful way to put it, I think. Yeah, hopefully we'll probably get there someday. Yeah,
We'll get there.
when Web3, yeah, I'm sure we get there. I think, like you said, when maybe when people use Web3, would start realizing they're using Web3 technology, then
Exactly.
I think we still feel, I would say, maybe a couple of cycles or several years away. So
Yeah.
anyway, but just keep building. Yeah, and the final question: where can
Okay.
people follow you or your company?
You can follow us
Yeah,
at accumulatenetwork.io, and you can do a Google search for accumulate protocol, and you'll find all kinds of links. We have a Discord you can join. We have um, Telegram, and you can reach us as developers, and yeah, through those channels.
awesome. Yeah, I'll make sure to put those links down in the show notes here so that people can follow, enjoy your Discord, and also your follow your website
Yeah,
and your podcast as well too. Paul, once again, thank you. I think Jay had already left
yeah,
1 hour ago, but anyway, thank you so much for joining today for this very long but very intriguing in our conversation. I think we've touched on so many different topics: Web3, entrepreneurship, supply chain, cryptography, quantum computing, some politics in there too here and then. But yeah, but thank you. It's been a very eye-opening conversation for myself. Yeah,
yeah. Well,
thank you
thank
for
you for
today.
hosting us on your podcast, and I wish you the best.
And we're back to my studio. What do you guys think about this episode with Jay Smith and Paul Snow? This is one of the few episodes where I think I touch upon a variety of topics with both the guests, ranging from Web3, entrepreneurship, supply chain, quantum computing, to even how politics affects the crypto industry. I think Paul and Jay are certainly pioneers in the field of Web3. I look forward to see how their vision for Accumulate Network will turn out. For the next episode, we'll be talking to Hash Rajat. He's the founder of Push Protocol. Push is the world's first blockchain agnostic decentralized communication protocol for Web3. If you enjoyed this episode, please like and subscribe. It would mean a lot to me. Thank you so much for watching, and see you next time.